polynomials. We'll start with the definition of a polynomial. Polynomials are a particular type of algebraic expressions that consist of variables and coefficients. So you would have seen a polynomial expression. Let's take a simple expression: x square plus x minus 12, something like this. So any expression with the variable and coefficients. So you can see other examples. So other examples of algebraic expression is 2x, 3x, so on, and can also have x cube plus 4x square plus 7x minus 5. So all these are polynomials. So we are going to see what constitutes the polynomial and also what doesn't. Okay. So these are algebraic expressions constitute a polynomial in single variables. Okay. So in one variable. So here we are talking about polynomials or the expressions in one variable. So if you notice all these three, we'll see that we are talking about only one variable x here. X. We are talking about, we have to find the value of x in these equations. So a variable is denoted by a symbol, right? So here we are talking about variable x. It can also be y, it can also be z. So it doesn't matter. So we can have any symbol as for the variables. Okay. So it can be 4y cube. It can be 4y cube plus 7. So it doesn't matter what variables you use. You can use any variables we want. We are consistently using polynomials. Consistently use x and then y and z. You can use p, q. It doesn't matter. All constitutes the a polynomial. So coefficients, whatever the values of the variables. For here, y cube has 4 as the coefficient. So the values of the variables is the coefficient. For coefficient of, so we are talking about coefficient of y cube. So here coefficient of y cube is 3, and here if you take this one, the coefficient of x is 2, and here 1 and 4, 7. Okay. What are the values that the variables associated with? Okay, so let's move on. 2x. Okay, so these are the coefficient. If you take let's take some more examples. 2x, 3x, minus x, minus 1 by 2x. Okay, so each term of the polynomial has a coefficient. Okay, let's take one more example also. X minus x cube plus 4x square plus 7x. Okay, so the coefficients are 2, 3, minus 1 in this case, 3 in this case, 2 in this case, minus half in this case. And here the coefficient of x cube is minus 1. This is coefficient for x cube, and for x square it is plus 4, and for x it is 7. So this is for the coefficient of the each variable is. Let's see what is a constant polynomial. Okay, so 2 alone, suppose we are having 2. Okay, so this alone is also a polynomial. Okay, what does this constitutes? This constitutes something called as constant polynomials. Okay, you can say 2 minus 5 7 other examples of constant polynomials. And 0 is also a constant polynomial, and it is called zero polynomial. Okay, so 0 constant constitutes to the zero polynomial. And let's see what doesn't constitute a polynomial. Okay, let's take an example. X plus 1 by x. This can be written as x plus x power minus 1. Here, minus 1 is not a whole number. Okay, so this does not constitute a polynomial. This is not a polynomial. Okay, so it has to be the exponential power to be exponential has to be a whole number. Okay, and one more thing we can talk about a polynomial is, so we can do the basic arithmetic operations such as addition. That means you can add one more. You can add one more polynomial to it, right? So you'll add the similar terms. You'll add the similar terms. So you can perform the addition operation between two polynomials. You can do a subtraction. You can do a multiplication involving two polynomials, but you cannot do division. Division is not possible. Division is not possible. And you can also be a positive integer exponent. So whenever talking about, it has to be a positive integer exponent is acceptable. That is also acceptable. Let's talk about the types of polynomials. So we're talking about three types: monomials, binomials, and trinomials. Let's see the examples of monomials. So we have 2x, 2, 5x cube minus 5x square. So these are constituted of only one term. Only one term. So these are called monomials. For binomial, we have x plus 1, x square minus x, y power 9 plus 1. So this has only two terms. Okay, these constitute binomials. Same for the trinomial. So we have u plus u square minus 2, y power 4 plus y plus 5. So we have three terms. So we have only three terms, they're called as trinomials. Okay, so let's see what is a degree. What is a degree of a polynomial? So degree is the highest power of the variable. For example, let's say we have p of x equal to 3x power 7 minus 4x power 6 plus x plus 9. The highest power of x is 7. So this exponent of 7 in this term is 7. We call the highest power of a variable in a polynomial as the degree of the polynomial. So the highest power of the variable is called the degree of the polynomial. The degree of the non-zero constant polynomial is 0. So if you take a non-zero constant, okay, suppose we have only one constant items, then the degree is supposed to be, it is a 0. When you have a polynomial degree 1 is called a linear polynomial. Suppose we have a degree as 1, for example 4x plus 5, 2y. So for these two expressions we have the degree 1. So this one is a linear polynomial. Next one is a quadratic. So we have power 2, 2x square plus 5, 5x square plus 3x. This constitutes a quadratic polynomial. And we have a polynomial 4x cube 2x cube plus 1. So here the degree is 3, and we have a degree 3, it's called a cubic polynomial. Let's see what is the zeros of a polynomial is. Zero of a polynomial is obtained by equating it to 0. Suppose we have an expression. Okay, then we say p of that x is equal to 0. Okay, so is a polynomial equation. We are equating it to 0. Okay, so that's the zeros of a polynomial. So we have an expression, and on the expression we are equating it to 0, and x is the root of the polynomial equation. So we say the value of x is the 0 or the zeroth of the polynomial or root of the polynomial equation. So when we have an expression, we can evaluate it to 0. For example, let's say we have an expression 4x plus 5. Okay, so the value of so we can equate it to 0, and we can find the value of x. That's minus 5 by 4. So x is the zeroth of the polynomial or the root of the polynomial equation. So we obtain zeros of the polynomial by equating it to 0.